Welcome viewers. In this video series we will continue from where we left in the last video. In the last video we learned about the property of differentiation or derivative when a function is multiplied by a constant. Like the property that we learned was that the derivative of k times fx with respect to the x, if we have to differentiate this k times fx with respect to the fx, so that will be a k times then simply derivative of the fx with respect to the x. This was the first property that we learned. And then after we learned that derivative of the function, suppose if two or more than two functions like fx dx and maybe any more than that functions are there, so if there are two or more than this, so this is simply like we derivate the first function and we put a minus or plus as is here accordingly, and then we differentiate the second function. So the derivative of sum of two or more functions is simply the independent derivative of those functions, okay, and it is added or subtracted like this. And finally, if suppose we'll also saw about the product rules. If suppose like two functions are multiplied and we have to differentiate this with respect to x, so fx and gx are two functions here. So when they are multiplied, so the rule is that we have to first of all derivate the first function. So let us derivate the first function fx. So that was like derivative of the function fx with respect to x, and we multiply it with the other function which is gx, and then we put a plus, we add it to the fx times derivative of the second function gx. So this rule is known as the product rule, and this is applied when two functions are multiplied like this. And we also saw an example for that. So before we further move on to the quotient rule, right now we'll first of all see a new formula, like what about some other functions, like what about the trigonometric functions, what will be the derivative of those and how will we use those. So like suppose the first and the most basic trigonometric function is sine function. So the derivative of the sine of the x with respect to the x, this is actually cos of the x, cosine x, okay, cos x. And if we have to, this is the first formula for the trigonometric function, and for the cos function, if we have to differentiate the cos function with respect to the x, then we can say derivative of cos x with respect to the x, this is equals to negative of the sine x. Sine's derivative is cos derivative is negative sine, okay, we put a negative here. So let us now use the these formulas in one of the questions, okay. So maybe if the question is like, if y equals to x to the 3 sine x, find dy over dx. So it's given like y is equals to x cube sine x. So what is the derivative of this function then? So we can say here y is equals to x cube times sine x. So these are two functions. We can consider the first one as the fx and the second one as gx, okay. And so we have to apply the product rule because these two functions are multiplied here. So to apply the product rule, we will first of all write it like dy over dx equals to, we can say this is like derivative of the x cube times sine x with respect to the x. Now if fx, we assume like let us assume fx equals to x cube and gx equals to sine x, and then we use the formula of the product rule. So that will be, this will be like the first function is fx, which is x cube. So first of all we need to derivate the x cube with respect to the x, and then we'll simply multiply it with the other function which we refer to as gx, which is sine x here, and then we'll put a plus, that is we add it, and then we'll simply multiply fx, which is x cube here, times the derivative of the gx, which is sine x here, okay. So this is the use of the product rule, okay. Now x cube, which is x to the n is 3 here. We have already discussed these formulas and you can watch the previous videos, please. I highly recommend you to see those videos. So this x cube derivative will be like 3 times x to the 3 minus 1, which is 3 minus 1 is 2, okay, and times, we just simply copy the sin x from there, and then we just copy the x cube from there. So it is plus x cube times, we right now just saw that derivative of sin x is always cos x, okay? And we'll sometimes also see the proof, we'll later on in few videos, hopefully we'll see the proof of this, okay? So right now just use it, the derivative of sin x is what? That is cos x. So this is now the result of the derivative of this function x cube sin x, which is obtained by applying the product rule. But we can simplify it, like we can take the x square as common from these two terms. So what will be left as it is with 3 sin x and then plus x cos x. So this is the derivative of the x cube sin x, or dy over dx. So this is our result. So this is how we apply the product rule in the quotient. Now let us see one more rule, which is known as the quotient rule, and that is also used several times. So let me add a new page now. So what is the quotient rule? Quotient rule. Okay, quotient rule is used when two functions are in the form of px over qx, or one function is divided by the other function. Like we just now saw that the product rule was used when two functions are multiplied. Similarly, the quotient rule will be used when two functions are divided. Like suppose if two functions are in the form of fx over gx, okay? If there are two functions and they are differentiated with respect to the x, so we can say this is equals to what? First of all, we'll differentiate the numerator, and numerator is what? Fx. So we'll differentiate fx with respect to the x, and we'll multiply it with the denominator, which is gx here, and then we'll put a minus here. That's the difference between the product rule and the quotient rule. It's a minus here, okay, in between. And always we start with this, we'll differentiate the numerator first of all, whatever is there, and then we'll multiply the derivative of the numerator with the denominator, and then we will just multiply the numerator by the derivative of the denominator, which is gx, okay, in this case. And then we'll just all of that over the whole square of the denominator, which is gx, okay? So this is the rule which is known as the quotient rule. Now just for a second I want to compare, or I just want to have a little bit of comparison between the product rule and the quotient rule. So you see the product rule was, suppose the function was fx times gx, okay? Yeah. So here we generally, if we use the same pattern just like this, so we can just copy it from there, and we can say the product rule and the quotient rule looks like similar, just as if we just look at the numerator part, but just the difference is that there should be a plus here, okay? This should be a plus. The derivative of the numerator times, derivative of the first function times the second function plus the first function times the derivative of second function. So this is how we can just remember these two formulas. And now let us see how we'll apply this quotient rule. So like for example, if we say, if the quotient is like y equals to maybe x square plus x over cos x, okay? Suppose this is the quotient, and we have to find the derivative of the y with respect to the x. What is the derivative of this function? So we can say, since y is equals to x square plus x, so we can compare it with the same form. If y is equals to fx over gx, so in place of fx we can say, like, if y is equals to x square plus x over cos x, so this is same as we can say fx over gx, okay, where fx is like x square plus x and gx is the cos of the x, okay? And now if we apply the quotient rule, this will be like derivative of y with respect to the x. This is same as derivative of what is this numerator, x square plus x over the cos x with respect to the x. So now first of all we'll differentiate the numerator, which is the fx, okay? So that will be the derivative of the x square plus x with respect to the x. As you will see here, the derivative of the numerator fx with respect to the x times the denominator, which is simply, in this case, is cos x, okay? So we'll multiply it with the cos x, and then we'll put a minus symbol, as is in the formula here. Okay, and we'll put fx here, fx times the derivative of gx. So what is the fx here? You see, fx in this case is the x square plus x times the derivative of denominator, which is cos x with respect to the x, and whole of that over the whole square of the denominator, which is gx, and in this case gx is cos x. Okay, so now we just need to apply the derivative formulas and simplify this if needed. So this will be x square plus x. So we know the derivative of x square is what? 2 times x to the 1, 2 times x to the 1, which is same as 2x, and plus derivative of x with respect to the x is 1. So we can simply do it in this shortcut way also. Okay, I hope you might have already practiced this type of problems. And now this cos x, we just multiply it. Okay, and minus, we just write this x square plus x, and times the derivative of cos is negative sine x, negative sine x. Okay, and then all of that over cos x square, and you know the whole square of any trigonometric function is always the square on the function, not on the trigonometric angle, not on the angle. So this will be cos square x. Okay, cos square x. So we can just bring this minus and multiply it with this one to get a plus over here, and that's it. I think that will be the result. So this is simply 2x plus 1 times cos x plus x square plus x, or maybe we can just take x as common, that is x times x plus 1 times sine x, and whole of that over cos square x. So this is our result. Maybe we can just go one step more if we just split it, like we know if there is any expression in the form of a plus b over c, this is same as a over c plus b over c. Similarly, we can split it like this is same as 2x plus 1 cos x over cos square x, and plus x times x plus 1 times sine x over cos square x. Okay, and the cos x cos square x will be gone, so this will be 2x plus 1 over cos x, and 1 over cos is sec x, so that is 2x plus 1 times secant x sec x. Okay, because we know 1 over cos of the x is this secant x, secant of the x, and plus this will be x times x plus 1, and this is sine x over cos square x. So we can write this as sine x, cos square means cos x times cos x, sine x over cos x is tan x, and 1 over cos we can write. Okay, because sine x is same as sin x times 1. Just to simplify this, we can say this is simply tan x times sec x, or we can say secant x times sin x, or secant of the x times tan of the x. So this is the simplified result. So I hope everything is I hope you like this video, and if there is any confusion, so please comment it, and if you have any doubt or questions, you can comment it in the answer box, or maybe you can email it to me on this email ID. Okay, mathstutorforw@gmail.com. So see you in the next video. Till then, take care, and in the next video we'll learn about basically we'll see some more trigonometric formulas and how to use them, and then we'll see some more good questions related to all of the things that we have done till now, and then we'll slowly gradually move on to the next part, which is the chain rule for the composite functions, how to differentiate those. So till then, bye bye, take care, and thank you for watching this video.